There's a loud bang, and then it starts. A battery module of an electric car is on fire in the Hagerbach test tunnel. A video of the test impressively shows the energy stored in such batteries. Meter-long flames hiss through the room and produce enormous amounts of thick, black soot. The visibility in the previously brightly lit tunnel section quickly approaches zero. After a few minutes, the battery module is completely burnt out. Ash and soot have spread throughout the room. Crucial information for multi-storey and underground car parks. The trial, which was funded by the Swiss Federal Roads Office (FEDRO) and in which several Empa researchers participated, took place in December 2019. The results have just been published. In our experiment we were considering in particular private and public operators of small and large underground or multi-storey car parks, says project leader Lars Mellert of Amstein plus Walthert Progress AG. All these existing underground structures are being used to an increasing extent by electric cars. And the operators ask themselves, what to do if such a car catches fire? What are the health risks for my employees? What effects does such a fire have on the operation of my plant? But until now there has been hardly any meaningful technical literature, let alone practical experience for such a case. With the support of battery researcher Marcel Held and corrosion specialist Martin Tuchschmidt from Empa, Mellert developed 3 test scenarios. Experts from the Hagerbach AG test tunnel and the French Centre d'études des tunnels in Bronn were also involved. We installed test surfaces in the fire tunnel on which the soot settled, explains Martin Tuchschmidt, corrosion and fire damage specialist at Empa. A parking space of 28 by 28 meters area and 2.5 meters floor height was assumed. Such a floor would have an air volume of 2,000 cubic meters. The fire of a small car with a fully charged battery of 32 kWh is assumed. For reasons of test economy everything was scaled down to 1/8. Thus, a fully charged battery module with 4 kWh capacity was set on fire in a room with 250 cubic meters of air volume. The tests investigated how the soot settles on tunnel walls, surfaces and on protective suits worn by firefighters on site, how toxic the residues are and by what means the fire site can be cleaned after the event. Scenario 2 – Fire in a room with sprinkler system. Scenario 2 deals with chemical residues in the extinguishing water. The test setup was the same as in Scenario 1. But this time, the smoke from the battery was channeled with the aid of a metal plate beneath a water shower that resembled a sprinkler system. The sooty water that rained down was collected in a basin. The battery was not extinguished, but burned out completely. Scenario 3 – Fire in a tunnel with ventilation. In this scenario, the focus of the study lay on the effect of such a fire on a ventilation system. How far is the soot distributed in the exhaust ducts? Do substances that would cause corrosion settle there? In the experiment, a 4 kWh battery module was again set on fire, but this time a fan blew the smoke at a constant speed into a 160-meter-long ventilation tunnel. At a distance of 50, 100 and 150 meters from the site of the fire, the researchers had installed metal sheets in the tunnel where the soot would settle. The chemical composition of the soot and possible corrosion effects were analyzed in the Empa laboratories. The results of the test were published in a final report in August 2020. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you new tech videos. Thank you.